Hello dear students, welcome. This question is from GATE 2018 exam. It's also a 2 marks question. Let's first read its statement. A 32-bit wide main memory unit with a capacity of 1 GB is built using 256M cross 4-bit DRAM chips. The number of rows of memory cells in DRAM chip is 2 raised to the power 14. The time taken to perform one refresh operation is 50 nanoseconds. The refresh period is 2 milliseconds. The percentage rounded off to the closest integer of time available for performing the memory read or write operation in the main memory unit is dash. Okay. So this is the information that they have given with respect to some memory unit. They are saying it is 32 bits wide and has a capacity of 1 GB. Also, it's built from this kind of DRAM chips. These are 256M cross 4-bit DRAM chips. What is the meaning of this? 256M. This means there are total 256M locations. So these locations or unique addresses, they will be 256M in number. Okay. M you very well know is 2 raised to the power 20. So it is 2 raised to the power 28 locations. Also, one such location, for example, this is one location. This will be of 4 bits. So this is number of location. This is size of one location. Okay. Now, let's see how many such DRAM chips will make 1 GB. So 256M into 4 bit. You can calculate it. This will be a total of 1 G bits. Okay. One DRAM chip, 1 G bits. Also, the total memory is 1 G bytes. So you can see such 8 chips will be required because one bit, this is 1 bit and this is 1 byte. To form 1 byte, you need 8 bits. So from 1 G bits, if you are using such memory chips, you will require 8 chips to form 1 G byte. Okay. Say these are those 8 chips. So these 8 DRAM chips are combined to form one memory unit. Also, you know DRAM or dynamic RAM is made up from capacitors. These capacitors, they lose charge over time. That means if they are not refreshed after certain amount of time, they will lose the information that is saved in them. That's the reason it is called dynamic. Also, they needs to be refreshed after a constant amount of time. This time is given as 2 milliseconds. This is called refresh period. So if this DRAM chip is not refreshed once in every 2 milliseconds, they lose the entire information that is saved. Now, this refreshing of DRAM chips will take some time. Okay, out of 2 milliseconds, first thing is after every 2 milliseconds, they will be refreshed. Now, out of 2 milliseconds, some time will be used in refreshing this chip. Okay, we are required to calculate the percentage of time which can be used for reading or writing. That means the time out of 2 milliseconds which is left over. Okay, that is after refreshing it, whatever amount of time is left, we need to find its percentage. That too out of 2 milliseconds. Okay. So you now know there are 8 chips. Second thing that you need to know, this chip can be refreshed in parallel to this chip. What I am trying to say, all 8 chips can be refreshed at the same time. So you just calculate the time required for refreshing one chip. Okay, that's your answer. Because all other will just keep on refreshing in same time only or in parallel. Okay. Actually, this chip is a discrete circuit. It can be used as it is. So that means it is going to have its own refresh circuit. So now, if you see, they have given you, there are 2 raised to the power 14 rows in every DRAM chip. 2 raised to the power 14 rows of memory cells in the DRAM chips. That means there are 2 raised to the power 14 rows of cells in this chip, as well as all other 8 chips. Okay. What is the use of this information? You need to know that while refreshing a DRAM chip, you don't refresh each and every cell. That means this memory cell, this memory cell, this, and so on. No, it doesn't happen like that. We refresh the memory chip row by row. So here, 2 raised to the power 14 rows will be refreshed. Okay, we refresh the memory chips row by row. Please note it in your notebook. Okay, now if one memory chip is 1 G bits, that is 2 raised to the power 30 bits. You can see how many bits are there in one row. So that will be 2 raised to the power 30 minus 14, which is 2 raised to the power 16. So each row, say this is one row and this is other row and so on. So each row is going to contain 2 raised to the power 16 bits. By the way, that is not required for solving this question. Anyways, now let's find its answer. So refresh period is 2 milliseconds. 2 milliseconds. 50 nanoseconds are required to refresh this DRAM. No, sorry, 50 nanoseconds are required to refresh one row. 50 ns. And there are total of 2 raised to the power 14 rows. So this much time will be required to refresh one DRAM chip. Okay. And in that time only all other DRAM chips will be refreshed. So you actually don't need to calculate how many chips are there. This much will just do the job. Okay, actually they've given main memory is 32-bit wide. This is not required for finding out answer. Still I'm discussing it. They are saying main memory is 32 bits wide. Here also it's clear that if one DRAM chip is 4 bits wide, they have given it. Okay, one chip is 4 bits wide. You have 8 such chips. So in total this becomes 4 into 8. 8 fours are 32. That's how they are saying it to be 32-bit wide. Okay. So all these chips combinedly form 32 bits of data. Anyways, now let's just solve it. So solving this, you will get how much time is used in refreshing. Okay, this is the time used for refreshing. You subtract it from 100%, and you will get your answer. So 2 raised to the power 14 is 16,384. This is going to be 16,384 into 50 nanoseconds by 2 milliseconds. So convert this 2 milliseconds into nanoseconds. This will be into 10 raised to the power 6. Yeah. So let us just solve it. One 6,384 multiplied by 50. This is 819200. Divided by 2 followed by 6 zeros. So this comes out to be this is 0.4096. Now you can multiply it by 100 to get percentage. Okay, so I think we must do it here only. Into 100%. Okay, so you can just cancel these 2 zeros with those 6 zeros. Anyways, so into 100%. Here also into 100%. And here also into 100%. So your answer, sorry, it's not answer. It's actually the time used in refreshing. This is 40.96. This much time is used for refreshing. So you can just subtract this from 100% to get the time that is available for reading as well as writing. That means for how much percentage of time the RAM is free for read and write after refreshing will be 100 minus 40.96. It is going to be 59.04%. 59.04%. Okay, this is your answer. And if they're asking closest integer, so answer is 59%. Actually they're asking for the closest integer, just round it off to get 59%. Okay, so this is your answer.